Alright, in this video is the start of a series of videos about factoring complex expressions. We're going to take a look at some special cases and look at some patterns here, and then we'll work up into some pretty complex, complicated expressions to factor. Alright, this first one is about difference of squares. What's that mean, difference of squares? Well, what we do is we have two terms here that are being subtracted, and those terms have to be perfect squares. In the second one, I have x squared minus y squared. So a perfect square means, can I factor a squared and split it apart into something being squared? Well, yes, obviously. A squared is actually a times a. And b squared is b times b. Okay, I can take the square root of that. X squared, of course, is x times x, and y squared is y times y. So we're looking for that pattern. And the word difference, of course, means subtraction. So we have to have a subtraction pattern in between. Alright, so how do you factor something like that? It simply becomes a plus minus pattern. In this case, we do a minus b, a plus b, and x. Now the pluses and minuses don't have to be in this order, but x plus y, x minus y. Now how does that work? You only have two terms here, and you end up having two binomials being multiplied. Well, the key is the negative sign here and the fact that these are different signs, because in using the FOIL method, I would get negative AB if I multiply those two terms together. And if I do the outsides here, it would give me a positive AB. And guess what? They would cancel each other out. So that middle term of, typically we'd get a trinomial, that middle term actually cancels out. And of course, in this example, we would get a positive xy, and we will get a negative xy. So that's the key. These middle terms drop out. Alright, let's look at some examples. 4x to the fourth minus 9. Now, the first thing is, does it fit our pattern? Is it a difference of two perfect squares? 4x squared, or sorry, 4x to the fourth is really 2x squared times itself, right? Okay, make sure that it actually is a perfect square. And 9, of course, is 3 times 3. So those are both perfect squares separated by a subtraction sign. So first of all, go ahead and put your plus minus in here, or minus plus, it doesn't matter. And then we want to know what multiplies by itself. So it would be 2x squared, 2x squared, and plus and minus 3. Alright, now if I use the FOIL method to check, I would definitely get 4x to the fourth and negative 9, and I would have two 6x to the squared middle terms, opposite signs, they would drop out. Alright, how about this one? What's the square root of 16x squared? How about 4x? Put it in both places. Then we have a plus minus pattern, and the square root of y squared is y, or 1y. So we can just put a y there, and our middle terms would drop out if we use the FOIL method. Alright, using some bigger numbers here, what's the square root of 81j squared k squared? Well, that would be 9jk. If I multiplied that by itself, I would definitely get that first term. So 9jk goes in the initial position, both binomials right there. Plus minus, and 64, the square root of that is 8. So we put an 8 in both places. Alright, on to another level of complexity. Alright, these two examples have to do with finding the GCF first. Okay, this is a really good tip when you're trying to factor an expression. Always look for the GCF, the greatest common factor, okay? Because at first you may not see the difference of squares pattern we've talked about. But if I look at the 27 and the 48, I'm thinking immediately, oh, I can factor out a 3 out of both of those numbers. And there's also a common factor of y. So let's go ahead and pull that out and see what's left. If I divide 3y in each part, that would be 9x squared minus, what's 48 divided by 3? Right, 16. And the y is already factored out. Okay, now look inside this binomial. Yes, you'll recognize the difference of two perfect squares. 9x squared is 3x times 3x, correct? And 16 is 4 times 4. So we're just going to break it down one more step And we're still going to have our two binomials here. It is difference of two perfect squares, so we have a plus minus pattern right there. And then I put our square roots in each part, so 3x and 4. 3x plus 4, 3x minus 4. Now if we had some spare time and had nothing else going on in our lives, we certainly could use the FOIL method to multiply it out and double check. But that's how you'd factor that expression. Look for the GCF first. What's the GCF here? Well, I noticed there's a y factor, one single y I can factor out, so that can go on the outside of my parentheses here. And what else? Oh, it looks like a 2. All right, so I'm going to factor out a 2y from each part. That would leave me with x squared and 16y squared. All right, notice that both of those are perfect squares. So let's go ahead and take the 2y on the outside still. And now we have two binomials. It's a plus minus pattern as we've talked about. And it would be x in both of these places and 4y in both of those places. All right, that's the expression factored out completely. Now for the last part of this video, what I want to talk about is something that maybe is not quite as obvious of a pattern. Believe it or not, this first example is an example of difference of two perfect squares. I have this binomial thing, y plus 1, it is being squared, and 36 of course is a perfect square. So what do I do with that? Well, think about it in this way. Let's say instead of this binomial I actually had a variable like x or j or something like that. Well, this would be easy to factor, wouldn't it? It would be this first thing here plus 6 and that thing minus 6. Okay, same pattern as we talked about before. So now what we're going to do is we're going to go ahead and make these, we're going to factor these out. And we know it's going to be a plus minus pattern. Okay, we know that the 36 is factored as a 6 and a 6, no problem there. But now we're just going to put this thing, y plus 1, in this little part here. All right, now I'm going to go ahead and just put it back in those little parentheses. And we just kind of picture it as one thing instead of two. Okay, it's a binomial. Now what's kind of interesting is if we have parentheses inside of parentheses, a lot of times we make brackets out of them. So it looks kind of messy now, but now we don't have too many parentheses in a row. So we have this thing plus 6, this thing minus 6. Now to simplify it, you'll have to check with your teacher in your textbook. Maybe you leave it in this form, or we simplify it here. This is really y plus 1 plus 6. So you could write that as y plus 7. And y plus 1 minus 6 would be y minus 5. Now believe it or not, if you use the FOIL method and multiply that out, it would give you this thing all multiplied out. So I could check that and multiply out that binomial and then subtract 36 and I really would have the same thing. So just a little twist in there in our factoring. Alright, same thing here. Now I notice that it's 25 minus and then I have this trinomial. Well, it turns out I can factor that and I can factor it as a perfect square. Not obvious at first, but when I think about it, that's going to be y plus 3 and y plus 3. All right, in other words, it's 25 minus that binomial squared. Okay, now it's similar to this thing up here. Think of this as just a single thing, like an x, a j, an l, or whatever. And that means I would have a binomial, and I would have 5 in the first initial position there and there. It's a plus minus pattern, right? Because it's difference of two perfect squares. And I put my y plus 3 in that spot right there. Okay, now these parentheses are kind of optional, but I just want you to see it structurally to see why it goes there. All right, I could change those outside ones to brackets if I want, but let's go ahead and simplify this. What is 5 plus y plus 3? Well, let's go ahead and put the number part first. That'd be 8 plus y. And what is 5 minus y plus 3? Well, that subtraction applies to both parts. So it's really 5 and negative 3. So it would be 2. And that y is being subtracted, so 2 minus y. All right, well, thank you so much for watching this video, and look for the next one about perfect square trinomials.